The shift toward decentralized energy, solar panels, high-capacity batteries, and smart grids is accelerating. But there is a distinct limitation with standard power setups. Without a constant stream of data, a battery is effectively a blind box. It sits passively against the wall, waiting for the grid to fail. To make this new infrastructure actually efficient, you have to see exactly what it is doing. Absolute visibility is the prerequisite. That is exactly what the PuRECloud AI and the smart ESS dongle provide. They act as the digital nervous system for the hardware, pulling a static backup unit into a fully active, managed ecosystem. The smart ESS dongle anchors this ecosystem. Rather than offering delayed, historical snapshots of your energy use, it streams live, high-resolution telemetry directly through its RS-485 and CAN interfaces. Looking at this multi-panel dashboard, we can see the data in real time. First, we track grid health by monitoring live voltage and frequency fluctuations. Second, load analytics reveal exact consumption percentages and surge trends, letting the system prioritize critical circuits if the grid drops. It goes deeper than the grid. These circular gauges track the internal dynamics of the battery itself, giving granular readouts on state of charge, total cycle counts, and live C rates, meaning exactly how fast the battery charges or discharges at any given second. And finally, this historical area chart monitors solar yield down to the individual string level. By comparing current output to past logs, we can spot physical issues, like a newly grown tree casting a shadow, or physical degradation on a single panel. This constant flow of telemetry builds a comprehensive digital cockpit. Every micro-transition of power is quantified, logged, and ready for analysis. Collecting data is only half the equation. Millions of raw data points do not mean much without a brain to interpret them. That is where the PuRECloud AI takes over. The AI engine performs continuous pattern recognition. Through load profiling, it learns your facility's specific consumption habits. It actively figures out the optimal moments to draw from the grid and when to rely exclusively on stored solar energy. This scatter plot maps temperature and voltage over time to illustrate predictive fault analytics. By isolating a slight upward drift in temperature, the AI flags a potential component issue and triggers a warning well before the hardware ever reaches a point of failure. We can also see the system execute time-of-use arbitrage on this 24-hour cost curve. The AI automatically schedules batteries to charge during cheap off-peak hours, then discharges stored power during peak expensive hours, all while keeping enough reserves to guarantee backup readiness. By executing these precise adjustments, the cloud AI turns a passive hardware asset into an active financial advisor that pays for itself. For commercial operations scaling across large footprints, this intelligence extends to multi-unit aggregation. Through the dashboard, fleet managers oversee multiple installations from a single unified view. They can assign tiered access roles, separating controls for the owner, the service partner, and the hardware OEM, ensuring the right people have exactly the data they need to maintain site-wide uptime. Because hardware configurations shift, the system uses over-the-air, or OTA, updates. The central cloud pushes firmware enhancements and parameter tweaks directly to distributed nodes, eliminating the cost and delay of sending a technician out in a truck. Connecting critical energy infrastructure to the internet introduces risk, which is why the data pipeline is heavily fortified. Every packet is secured with end-to-end TLS and SSL encryption. Furthermore, strict hardware authentication immediately blocks any unrecognized device trying to communicate with the cloud. Behind this security wall is a permanent ledger of system events, securing an accurate audit trail for warranty claims. If strategy must shift for a storm, users can bypass the AI entirely, manually toggling the system into grid priority or solar first modes. This combination of remote agility and tight digital defense means the energy network scales easily, but remains completely secure. What we have built is a complete technology stack: physical batteries guided by high-resolution sensors, interpreted by predictive cloud computing, and protected by hardened networks. The end goal of this architecture is to translate raw, unpredictable electrical behavior into clear, actionable business intelligence. By continuously optimizing when power is stored, when it is used, and when it is bought from the grid, the system delivers zero gaps reliability while systematically driving down the total cost of ownership. It acts as the definitive intelligence layer for modern energy. It ensures your infrastructure is always visible, completely secure, and continuously running at peak financial efficiency.